Very good morning. Today we'll discuss mathematical induction. So actually this method is how we can prove the given statement. Okay. What are all the steps we are having for this method? First step is basis. Second step is induction. The basis you have to take it as a very small value. Let you take assumption n is equal to 0 or 1. You take a statement, apply these values whether the statement is true or false. Okay, how to prove it actually. For this induction is how we can solve it. Greater than your basis value you have to apply and you have to check whether a statement is true. So actually for the induction you can take it as if s of n, then you have to prove s of n plus 1. What is this meaning is you take a assumption s of n is true. You have to prove s of n plus 1 is also true. Okay, this is assumption. This is how to prove it. If you prove means the given statement is proved. Okay, we'll see one example for this mathematical induction. Okay. For example, prove that 1 plus 2 plus up to plus n is equal to n into n plus 1 by 2 using mathematical induction. This is a question. So, first I'll start from basis. Before that, you have to write a statement also. So, S of n is equal to the given statement. Whatever the problem you are having, that you have to take it. So, the statement is 1 to n is equal to n plus 1 by 2. The basis is you take assumption let n is equal to 1. Okay, you have to prove your left hand side and also right hand side has a equal value. So, I'll consider my left hand side. So, n is equal to 1. So, first term alone I'll take it. What about in the right hand side? So, I have to substitute wherever n you are having, that place you can substitute 1. So, now the right hand side value is n into n plus 1 by 2. This is equal to, you can substitute 1. So, 1 plus 1 by 2, this is equal to 1. Therefore, the left hand side value is equal to right hand side value. So, your basis is true, right? So, S of 1 is true. Okay. Now, we have to take the induction. So, I'll tell you. The induction. Okay. Assume that S of n is true. Okay. What do I have to prove it? So, S of n plus 1 is also true. Okay. This statement is true. You can take assumption. So, we have to prove S of n plus 1 is also true. Okay. So, this is S of n statement. We need a statement of S of n plus 1. So, that I'll write. Okay. 1 plus 2 plus up to plus n plus 1. Wherever n you are having, that place you can substitute n plus 1. So, here is also, so n plus 1 into, this is n plus 1 plus 1. So, I can write it as n plus 2 divided by 2. Okay. Right hand side part is already simplified. So we have to simplify only the left hand side part. That should be is equal to the same value of right hand side. Now I'll take it as a left hand side part. So 1 plus 2 plus n plus 1. Okay. Oh, so what is the previous term of n plus 1? Sure, it is n, right? So I'll change 1 plus 2 plus n plus 1. Up to this statement is already true, right? So the output of that statement is n into n plus 1. So I'll substitute here n into n plus 1 by 2 plus n plus 1. Okay, now I can simplify the statement. So this is equal to n into n plus 1 plus 2 into n plus 1 by 2. Now I can take a common value outside. So n plus 1 is a common value. So I'll take it out. Balance is n plus 1 into n plus 1 by 2. So actually this is equal to right hand side part. So now the left hand side and right hand side is equal, right? So therefore, hence this given statement is proved. Okay. So like that, you have to prove the mathematical induction. So sometime they'll give a question like 3 power n plus 2 is divisible by 3. Like that, they'll ask some question. So what I have to do, you have to solve only the basis and induction method. So both sides have to check it as equal values. Thank you.